Hello and welcome to the Ways of Math. This is Dan the Math Man, your host, and today we're going to start a new series, this time on the introduction to basic probability. Before we get started, please be sure to subscribe so that you can be notified of our new videos. And always, if you have any comments or suggestions, please leave them in the comment box below. So today's series on introduction to basic probability. So this is going to be focused for people who are taking a class that might have some concepts of basic probability. This will not, however, rely on set theory as most probability does. We might reference set theory in a couple different parts, but don't worry about it, don't stress about it. We won't rely on set theory notation or a lot of the concepts from set theory. We'll try to just describe the basic idea of probability and some of the overall concepts related to it. Also, please be sure to note I will be adding appendix videos to this, which don't fall into any particular part in the order of the series. But for those who might be unfamiliar with certain types of exercises that will be done in probability, please be sure to check those out as they are posted. So today is part one. We're going to be just kind of doing an introduction, kind of what is probability and that sort of thing. Right, so as I said in this video, we're going to be discussing what probability is. So what is probability? What is it used for and why? We will also get some early definitions, right, to kind of give a mathematical framework or groundwork in order to start developing the concept of probability. We will also define empirical probability and theoretical probability. And of course, we'll see some examples that kind of help motivate understanding about these concepts. So begin by asking, what is probability, right? This is probably the most obvious question that we can ask. So loosely speaking, probability is a numerical value that determines the likelihood of an outcome. Okay, now historically, we've always sought to kind of determine how likely something is to happen. Everything from weather forecasting, finance, medicine, genetics, opinion polls, elections, you name it, gambling. I mean, everything. Human beings have always been interested in being able to find a means of predicting what might happen or whether something is likely to happen or not happen. Now, mathematically speaking, probability is the field of study that helps us to determine these sorts of events or phenomenon mathematically. So we want to be able to precisely determine how likely something is to happen. So within a mathematical framework, so we want to add this level of precision and rigor that mathematics expects of us in order to kind of determine the likelihood of something happening or something that has happened or even something that will happen. Now, before we get ahead of ourselves, we do need some mathematical framework to build on. So let's head into some definitions. So first we want to define an experiment. Okay, so this is a term you'll hear a lot in probability. In fact, all these terms you will hear regularly in probability. So we want to make sure we understand what they mean in terms of the framework of mathematics. So an experiment is a controlled operation that yields a set of results, and these results are called outcomes. Okay, so think of an experiment as, suppose you want to roll a die a bunch of times, or flip a coin a bunch of times, or maybe draw a card out of a deck. So we're kind of repeatedly doing the same thing, okay, multiple times. So that's what an experiment is, okay? Sometimes you'll hear trials, right? So we're performing trials. That's kind of synonymous with the term experiment. Now, notice this is controlled by the individual performing the experiment. So there's where the control idea comes in, okay? We also want to define outcome, right? As we kind of already mentioned it, kind of alluded to it. The outcome is, or a possibility, or rather the multiple possibilities, rather the results of an experiment. So if you perform an experiment, for example, it's the result of one of these experiments or one of these trials. So again, kind of following the idea of examples we established above, the outcome are like the numbers rolled. So rolling a die, it's the outcomes are the numbers that are rolled, or numbers that are face up when we roll the die. Or if we flip a coin, whether the coin lands heads up or heads down, so tails up, or the specific card that's drawn. So these are the outcomes of each trial run in an experiment. We also want to define an event. So an event is a collection, okay, or a set, for those who are kind of set theory minded. If you're maybe watched my videos on set theory, introduction to this kind of sets, then you'll be familiar with these terminology. But it's a collection, okay, or more precisely, it's a sub-collection or a subset of outcomes of an experiment. Okay, so this could be a specific outcome, or it could be a series of outcomes, or types of outcomes, or groups of outcomes. So it could be a single element, which is a single outcome, or it could be multiple elements. It could be multiple types of outcomes. So that's what we talk about when we say an event. Okay, so again, thinking of an event in terms of specific outcomes, it's like rolling a 2 or a 6, right? That might be an event. Those are two different outcomes, the 2 or the 6, but we might consider the event as being either rolling the 2 or the 6. That's a single event. Or maybe landing heads up or drawing a face card. Right? These are events. And so we can have multiple outcomes to these events, or we could have a singular outcome. Right? Like with the case of the coin, a single head up is maybe an event. That's an individual outcome. Versus drawing a face card, there's multiple cards, multiple outcomes that satisfy the face card. So again, for those of you familiar with set theory, an experiment we can think of is a set of elements called outcomes, and the event is a subset of those outcomes. Again, that's for those who are familiar with set theory. Don't worry if you're not. However, if you would like to know more on set theory, I do have another set of videos on introduction to sets, and that will give you the groundwork or the framework to understand the concepts related to sets in this series. Moving on. So here's kind of a more informal definition, kind of the idea mathematically, but it's still kind of informal. But a probability is a function, p, usually it's called p, with the input being an event, sometimes called e, or they could be a variety of different names. We can call the events whatever we want. Okay, but it has an input that's an event, and whose output is a numerical value that ranges between 0 and 1, and that's inclusive. So we could have a probability that's 0, or a probability that it's equal to 1. Now we think of the probability output of 0 to mean it's impossible, that the event can't happen and will never happen. The output of 1 we interpret as meaning that it's guaranteed or must happen. Okay, so if you take the probability of an event and we get the probability is 0, then that means that event can never happen. If we get a probability of an event and we equal 1, then that means that event must happen. It's guaranteed to happen every time. Now, every number in between is kind of a measure of the likelihood of the outcome being in the event that's in question. So if we're closer to the value of 0, then that means it's less likely to have that outcome. If it's closer to the value of 1, then it's more likely to have that outcome from that event. Okay? Now, there are different types of probabilities that we study. We're going to kind of focus on 2 of them, at least in this video. And those are known as empirical probability and theoretical probability. Now, it's very important to understand the distinction between these, as they're found in different methods, and they're used differently. So we're going to begin with empirical probability. So empirical probability is an experimental probability, right? It's related to the frequencies of occurrences, so how many times something has occurred over the course of an experiment. So the outputs for an empirical probability function are determined by the experiment and the relative frequencies that were observed by that experiment. So if we have a particular event that we want in question, we have to run an experiment. So we have to have kind of a set of outcomes that we've determined by running the experiment. And then we interpret the empirical probability by the relative frequencies, okay, of how many times we've noted that a certain event has occurred. So formally speaking, we can say the probability of an event E, if we're dealing with empirical probability or relative frequency, is the number of times that the event E has occurred, right? So the number of times that the outcomes in the event have been observed, and we divide that by the total number of times the experiment has been performed. Okay. Excuse me. Now let's see an example of this. So suppose you roll a 6-sided die. Each side is equiprobable. Now, equiprobable simply means that every outcome is as equally likely to occur. Okay, so like a 6-sided die, we generally consider if it's not weighted or doesn't have more sides, like there's multiple sides that have the same number or same digits on them. Okay, so all 6 sides are different and they're all equally likely to happen. Okay, that's essentially the idea of equiprobable. Commonly, you also hear equiprobable in reference to a die or a coin as being called fair. So a 6-sided die or a 10-sided die that has equiprobable outcomes on rolling is called a fair die. A coin that has equiprobable outcomes for either side is called a fair coin. Okay? So now suppose we take this die and we roll it 15 times, and suppose these are the outcomes, right? So these are the numbers that we rolled, right? So this is the number 1, the number 2, 3, 4, 5, and 6. So these are the faces of the die. And this is the number of times that we recorded these faces occurring. So the number 1 was rolled once, the number 2 was rolled 3 times, the number 3 rolled twice, the number 4 rolled 4 times, the number 5 rolled once, and the number 6 rolled 4 times. So notice the number of occurrences must equal the total number of times that we did it. Otherwise, we're not accounting for something. So all the total number of times it was rolled, we have to record something every single time, whether it's a repeat or not. Okay, so you notice that the sum 1 plus 3 plus 2 plus 4 plus 1 plus 4 is 15. Okay, now based on this experiment, we can compute the probability of getting a 2 on the next roll. So this is just kind of estimate the likelihood of a 2 occurring based on this outcome or based on these relative frequencies for this experiment. Okay, so by using the definition of empirical probability, we take the probability of rolling a 2 as equal to the number of occurrences that we observed 2. Right, so we see 2 was observed 3 times, divided by the total number of trials. So remember, we rolled the die 15 times. So we observed 2, the number 2, 3 of those times. So 3 over 15, which reduces to 1 over 5. Okay? And probability, it depends on the size of the number. A lot of times we like fractions, but sometimes the probabilities might be really small, so or might not be very easy to express as a fraction. Sometimes we also like a decimal form. So you might see answers either by your instructor or in textbooks that might show both the fraction or the decimal answer, but they're both equivalent. So 1/5 is our probability of rolling a 2 on the next roll, or 0.2 is our probability. Okay? Now let's consider theoretical probability. Okay, so the concept of theoretical probability, in general, when you hear people use the word probability, whether it's in a course or you hear it in the real world or you hear it in news articles or you hear it on the radio or you hear it on television or etc., if you hear the word probability, usually we're talking about theoretical probability. Okay, so theoretical probability doesn't require an experiment, doesn't require that we observe frequencies. We simply compute the number of possible outcomes versus the number of what we consider favorable outcomes, right? And so this leads us to our definition. So for probability of an event E, given the scope of theoretical probability, is the number of outcomes that are favorable to E, so just the total number of outcomes in E. Again, for those of you who are set theory savvy, this is the cardinality of the set E, or the event E, divided by the total number of possible outcomes. So this is, again, in set theory, the cardinality of the universal set. Okay, the set that we're talking about for all possibilities. Okay? Now, notice I have a little asterisk here. This form of theoretical probability is only really usable if all outcomes are equiprobable. So if every outcome has the same probability as every other outcome of occurring, then we can use this. We can definitely apply theoretical probability, as we'll see later in later videos. how to apply theoretical probability to other types of situations where we don't have equiprobable outcomes, but then we account for the fact that they're not equiprobable, and we kind of adapt this formula to be used as such. But for now, we'll be dealing with it in terms of outcomes that are equiprobable. So we just compute the number of outcomes favorable in an event divided by the total number of possible outcomes from the situation. So now notice the difference in wording between empirical probability and theoretical probability. So again, here's a very clear distinction that we want to understand. Empirical probability comes from an experiment and deals with the relative frequencies of observances, while theoretical probabilities come from just possible outcomes, assuming that they are equiprobable. But even if they're not, we can still apply theoretical probability. But theoretical probability doesn't require an experiment in order to interpret results. It's simply an abstract guess, an educated guess, if you may, about the possible outcomes, so the relationship of possible outcomes versus favorable outcomes. Okay, now let's go back to our previous example, and we'll look at it in the scope of theoretical probability. So again, suppose we have a six-sided fair die, so all outputs are equiprobable. Compute the probability of rolling a 2. Now just in general, we're just computing the probability. So we're not running an experiment, okay? We're just anticipating what do we expect to see as being the probability or the likelihood of rolling a 2. So again, that's the phrasing difference that we want to notice. We're not doing an experiment. We haven't performed an experiment. So we infer, in this case, we're asking for theoretical probability. And as I said above, since it's a fair die, each outcome is equiprobable. Okay, so we can use the formula that we had in the previous slide. And there are 6 sides on the die, numbered 1, 2, 3, 4, 5, and 6. Okay, we're using just a standard die. Usually when in exercises and questions, when we talk about a 6-sided die, we assume they're distinct, whether they have numbers or letters on them. But in this case, we'll just assume numbers just for organization. Now our favorable outcome is 2. That's what we're asking for, the probability of rolling a 2. So 2 is exactly one of these 6 sides. Okay, so that means the number of favorable outcomes is 1. There's only one number 2 on the dies. Now the number of possible outcomes is 6 because there's 6 sides to the die. There's 6 distinct faces on the die. So using this definition that we encountered previously, the theoretical probability, then the probability of rolling a 2 is 1 in 6, 1 over 6, or 1/6. And again, if we want to express that as a decimal, this is approximately 0.16667, or however many decimal places you want to round that to. Okay, so we see the difference between theoretical probability and experimental probability. They're not necessarily the same thing, and as we'll see in later videos, that's actually related to the number of times that we perform an experiment. Okay, but for now, just understand that with experimental probability, which is based off of the relative frequencies observed in an experiment, the answers for the probabilities might be different than what we observe with theoretical probability, or what we compute with theoretical probability. Okay, so let's kind of review some of the important facts we talked about. So the probability of an event equaling 0 means that that event cannot occur. It's impossible. If a probability of an event equals 1, then that event must occur. It has to happen. It's guaranteed. The probability of every event, no matter what kind of event we're talking about, ranges between 0 and 1, and it's inclusive, so it could be equal to 0, equal to 1, as we talked about. So that means for every probability of any event, the value, the output of the probability function, is always between 0 and 1. Now, we'll just observe this and take it as a fact. We'll discuss it more later. But the sum of all probabilities in any experiment or any even theoretical case has to equal 1, right? Essentially, all that means is something has to happen, right? So either something happens or it doesn't happen, right? No matter what the possibilities are, the probability of each of those possibilities, if we add up all of these distinct possible outcomes and we take the sum of all the probabilities of those, they have to equal 1, because something has to happen. right? And with a probability of being 1, then something happens. So something has to happen when we add all these probabilities up. Empirical probability requires experimental values, so they require these observed frequencies or these relative frequencies in order to apply empirical probability. While theoretical probability, which again is commonly referred to as just probability in most contexts, does not rely on experimental results. It's purely a theoretical construct that relates the number of favorable outcomes to the number of possible outcomes. That's it for this video. I hope you enjoyed watching it. Again, thank you so much for watching. Please be sure to subscribe and leave any comments or suggestions in the comment box below. I thank you again. Have a wonderful math-filled day.